Hey everybody, this is Brad Dyke saying hi. Reaching out to you. This is a future hardware construct video. It's about how the IT operations environment can communicate in the future differently than how we see it today. It has to do with a lot of very innovative individuals out there, but I take some of those natures and I put them together and I kind of see them in a slightly different way to be very beneficial, hopefully, in the future. So what we're going to talk about here today is if you can see back here, you see the rack enclosure environment that we have. Now, if you look inside that rack environment, you will see that there is quite a bit of wiring, right? As you can see, we have our tiered structures, and of course I powered everything off so I could actually talk to you. But we also have other forms of wiring out here. So if we turn around the corner here, we can see that we have KVMs, we can see we have fiber optics, we can see we have 100 gig, 10 gig, and other types of cabling sets in here. And of course on the next rack it's even more spaghetti mess because these devices up here, here, and here require a lot of segregated communication bus cablings, which you can see right here. Now, all in all, it's quite a mess. So, messes are messes, right? When you have cabling, it's just a fact of life in this industry. But what if you were able to take existing technologies off the shelf, what we call commercial level COTS, systems, platforms, even software. We take them off the shelf and we turn around and we turn them into something different. What if there was only one cable required for every device? A single cable doing one task. Power. That's it. Power. Now, that's impossible, isn't it? Because there's no way that a device interface could be functional any other way. There's no input. There's no output. It's just an isolated box with power. Not necessarily true. What if we were able to take a box, put a multi-spectral transceiver on board, and let's say we have 5 sets of transmitters and receivers, each one representing one thing. One is video, one is USB, another one could be FireWire, another one could be internet, as in Ethernet connectivity, and so on and so on. What do you need for a mouse and keyboard? USB. So wireless USB is feasible. And it already technically exists in a certain way. It's just that we put a transmitter set in the core system and the wireless mouse is using the transmission cycle to send its activity to the receiver on the other unit. That receiver looks very similar to this. So, what if we were able to have 5 of these, USB, Ethernet, Bluetooth, bridge, RAID, as in storage protocol, and video? How many would we need? On average, 5 sends and 5 receives. Or in other words, 5 transmitters and 5 receivers, right? Working at different radio frequency levels in a low yield output in a defined area. But what could take and coordinate all of that and find the right device that we need? Well, that's easy. It's sitting right here. A standard switch, except the only difference with the switch we need versus the switch we have is it has to have on the sideline the 10 sets of transmitter loops that it can handle. So if we can get a network switch that is not a network switch, that's the secret. It is a workload switch handling 5 separate forms of wireless communication that each and every one of them carry at least 128-bit encryption or even higher, 256 or 512. And they're interrelational, which means they cannot ever travel over each other's frequencies. That's a little complicated. Yes. And does that switch exist today? No. Could we conform hardware to make that switch? Yes, we can. We can do that. The question is, which one of those vendors out there is going to take the time and put that together? Because if you can develop the standalone interface device with its antenna, literally, I kid you not, yeah, everything could work on that. Wi-Fi SDH. That's Wi-Fi transmission storage disk functionality. You could use it in a simple format, put some more invested energies in it, and you could build yourself 55 disks, all only requiring power, sitting somewhere casually in the room, not really needing to be in a rack or to be stacked or anything like that. All they need is power, but they all communicate to the storage protocol Wi-Fi signal, each taking their slot just like SCSI disks do, 0, 1, 2, 3, 4, 5, 6, and so on. All taking their homes, getting their information, and start transferring read and write cycles. Now, that doesn't mean the industry is going to be super fast, but for internet traffic and internet storage traffic requirements, it doesn't have to be super fast. It just has to be faster than the incoming connectivity. That's it. That's all it takes. So, with that being said, you could have USB devices, all of them, scanners, you name it, could communicate on that same device network. And all they have to do is go to the device that wants to use it or become an open device that everything in the house can use. That's thinking outside the box. Imagine that. You have a wireless network environment that's got all 5 levels of protocols or more. And don't just rely on my review. We could add additional protocol stacks in there like FireWire and so on. And the end result is every device that's Wi-Fi based and can work on one of those channels, because the industry would have to be reinvented. They'd have to add the protocols to the wireless stacks that belong to the devices, and then you have a workable environment. So for those guys and gals out there in the industry looking for a new product or a new industry to make, this is definitely in that category. This also works extremely well for Internet of Things interfaces, because I've been on that side with Ford Motor Company and the way they wanted to use IoT to do their production and many other things to get a micro content detail of how their systems are running and how they can be more efficient and so on. This cutting the wires out of the equation is a big plus, because you can hang stuff anywhere. You can even put it in the concrete floor. As long as it's got power and it can reach the signal to its master switch, you're fine. You're good to go. So that's something to think about. So with that being said, to have the ability to redefine the word network, it's not TCP/IP anymore. We already do this to a degree, but it's limited and it's siloed. This type of technology standard would unsilo it all, making a single concept device, i.e. a network switch of a whole different class, that has all the internet traffic you need. It can do the 100 gigabit pipe connections, and it can also have infrastructure connections for other kind of switches and things like that, as well as having the transceivers that you need at the different frequency levels, so that you can accomplish the ability of connecting all of your internet devices together. Now, the last part of that is, and it's a very simple answer, because I'm like the good Lord. Good Lord never puts anything out that's complicated, because there's so much of it. And that, this keeps it simple, stupid. How do you make all this? How do you manage all those devices together into a form? Well, it's pretty simple. I think the best way to look at it is if you look at how certain wireless access points are configured with a common internet browser tool that allows you to attribute and configure how the access points function and identify all the device nodes that are out there. You can actually pair the devices either in a common browser for the whole house, and you have 100% control. Nothing else can be defined except for you in that browser state. Or you can allow pairing sets. In other words, if you hit a request on a PC and you've got a wireless keyboard and you hit the Bluetooth announcement key, the PC will see the keyboard and they'll pair. And so you can take the complexity of total control out of the equation and just you pairing to pairing states. May they be anything from an iSCSI style, like a communication process from a hard drive to a station back to a hard drive. And all you do is you pick up that hard drive review. Let's say in this case, you've got an ID number on it. The ID number is Alpha Charlie 122, and you look for Alpha Charlie 122 out there and you pair the drive. And if you need to pair more of them together, you can. And then it says, oh, I see 4 hard drives out there. What would you like to do with these hard drives? Do you want to make a RAID group? You know, do you want to create a redundant array of inexpensive disks that are wireless based? And it said, yep, make it happen. Now, again, we're not talking about the performance levels. We're talking about ease of deploying a lot of gear on 5 different bandwidths in a house, right? Or in a building. And this is something that's even more feasible with environments like businesses, because here's the business pitch in this discussion, and that is the individual switching configurations can be put into what's called an encrypted lock state. An encrypted lock state means that no other device in the area of this switch is acceptable. What does that mean? Well, if nobody can get to the switch, nobody can get the traffic from the switch. One of the most complicated situations about networking hacking is getting into the cable. And getting into the cable means that you can splice in and you can pick up the TCP traffic and so on and so on. But if there are no cables in the equation, except the one ISP cable, and that could also be addressed by a wireless encrypted pairing as well, and there's no cable at all, everything inside the building would be secure to a lockdown pairing process. Now, it's extremely controlled. Nothing can communicate inside those 10 buses except those devices, because the devices announce the IDs and the network switch locks them in. And unless you manually go in there and you get into a port or something and connect to change those values, nobody has the rights to change them on the exterior. Only the way you set that up. And that's usually done by a console cable that would go to a console switch. And of course you think, oh, well, then I'll attack it from the console switch. Yes, that's true. If it's plugged in. There's the trick. I'm a major fan and component of breaking the rules about getting hacked. Yeah, you always go under the radar. You look like you're not somebody you want to hack. And when you go in there, you break the standards for those things they use to hack you with. You have to literally approach anti-hacking that way, because in a switch mode environment, you have to constantly think that way. How can I get in? How can I get in? How can I get in? And the only way to do that is to actually have a kill port on a network switch. We've used them a lot of times. And that kill port is physically disconnected. So you have to go in, you have to take the screws off the little plate that hide the port, and you got to plug your cable in. And frankly, if you're inside the building able to do that, well, forget about hacking. You've got bigger problems, right? Because you had to go inside to break the system and just start to see if you could hack it, because they still haven't done anything. They got onto the console, but they've got to go through the console security process, authentications and all of that. Then they got to get in and break the pairing so they can add themselves into the equation. Quite a complicated process that you got to try to get done in a very short span of time. Can it be done? Everything can be done. That's an oxymoron statement. That just doesn't apply. But the goal is you make it painful and as painful as you can make it, so the hacker realizes, because he's the one on the time loop, not you, who's easier to hack than me. And they move on. See what I mean? So you have to have that strategy when you think about such a device as a multiplexing style transceiver network wireless only mode for everything. And that's something that's pretty cool. The last part of it is called, and you probably wonder, you say, wait a minute, if I want this mouse and this keyboard and the scanner and these 5 hard drives to work for workstation B, and I want 2 hard drives, a keyboard and a digitizer and a 3-dimensional scanner to work for workstation Bravo, and then over here I have a data entry NAS platform and it needs 24 hard drives. Well, how do I disseminate all that information? Very easily. When you pair to the parent application, and in this case, application means the workstation, right? Anything that has the ability to process or handle devices, input-output devices. And that's usually referred to as the unit that has a CPU in it. That card, that interface will give you a key. And it pairs up with the network switch to your manager and say, okay, I'm giving you a key, give me back the key. And if I get the key back to you, from you and it's correct, I'm going to open up, please assign devices to me. And you go in there, you literally just drag and drop all the devices to that. Let the protocols handle, the sharing and all of that. They'll communicate and transmit a set key to the workstation. And at that point stage, you disengage from the network browser side of the network switch, your key connection, and that workstation is from that point on functional. And you don't have to interact with it again, unless you want to add more devices, like a new printer, and so on and so on. You can also do the pairing across multiple workstations, like you've got a laser printer in the house, and it's a Wi-Fi device, and you want to say, okay, this Wi-Fi printer, you're going to station Alpha, Bravo, Charlie, Delta, and Zulu. And all those workstations will work off that one printer. And then in the next printer set for the next room, and so on and so on. Again, because the network key has the keys to these workstations, it will automatically allow them to connect to each other using the laser printer. And so what ends up happening is the protocol interface, that's your network neighborhood, or your USB controller driver, or your wireless iSCSI bridge connection, and so on. Each of your port communication levels, Bluetooth, and so on. They'll show you that device ready for use. Load the software drivers for it, you're operational. And all 24 of these devices could do that. Could you develop it in such a way that the devices hand their drivers over to the workstations? May it be any version of operating system? If we had followed USB correctly, Universal Serial Bus Standards, yes, but that's not always the case, and not all protocols work that way. So there'll be some level of configuration requirements depending on that. But this is a futuristic view of what I see a network switch evolving to next. Now, the last part of this is for the enterprise level customers. How does such a switch, we're talking about a $400,000 switch that would own like that top panel you see there, which is an 8U or a 10U footprint. And it has thousands of, pathways, and it has blades of network ports and so on. But those ports aren't there for the communication process. What I'll refer to here in just a second, once I show you this image, it can do something totally different. So, how would you use this technology in an enterprise environment? Let's say you're Ford Motor Company and you have a manufacturing plant and you have 25 lines, each line representing a business unit. And inside those business lines are Internet of Things devices that are doing different tasks, tracking executions, and so on and so on. Well, very easily. So imagine you have this big box sitting inside your rack enclosure at that factory, and it has blades in it, and each one is a Cat5 bridge connection that kind of acts like a power over Ethernet, or can communicate like power over Ethernet connectivity. Let's put it that way. But what you don't have on the end of that power connection is a network device. That's right. Instead, you would have something very much like one of these. Except in this case, it is not a single stack antenna, but it is compressed of 10 state antennas that connect to the cable feed and communicate for all the identified targets in or around the business unit. In this case, let's say it's line production 10, and there are 20 internet devices in there that are acting as IoT devices. And when you power them up with this guy monitoring, it will sense them they will identify them and categorize them and log them by their broadcast names. And then that becomes the business unit for this transmitter. Okay. And this is a receiver as well. So you have a cable coming out that hooks up to this from the switch, but you have hundreds of these going out, and it spreads the antenna mindset out. But by bringing the Internet of Things devices in sections, you can very quickly tag those units, prep them, bind them by their classifications to the script files that will immediately identify their taskings, and bam, you have your quality, your quality and assurance devices tagged. You've got your pressure sensor Internet of Things devices tagged. You've got all the other versions of devices that work on IoT tagged, and you did it in probably no more than 10 minutes. Now that is a money saver on a major scale, because any of us who've done IoT deployments, you don't get nothing done in 10 minutes, not effectively. But if you do your processes right, and you're able to bring the devices in small groups, pre-state and with a preset script, and these are the only guys that belong to that one transmission loop sitting on that one port on that one switch of 500 or 600 ports, all of a sudden simplicity does come into the effect. Does sound like DevOps, doesn't it? In a kind of a certain way, but it's not integration as much in distribution as it is seamless preparation, which is more accurate. So, like I said, this is an idea for all of you integrators out there who know the technologies I'm referring to, may it be from Bluetooth all the way to wireless transmission devices for storage devices and microwave transmitters, you name it, whatever format of wireless communication. You absolutely can have the ability of putting it into a single repository switch. Now, that doesn't necessarily mean that the switch is going to look like a 19U footprint switch. It could be a dome. It could be an L-shaped weird device. It has to be on the top of your building. I don't know what it would look like. I leave it to the younger minds to figure that out. But this is the culmination of seeing these things out there, having to set them up separately and thinking, wow, man, why can't we get this all into a single solution? And then bring that to the table, even for a couple of them. Like, you know, wouldn't it be nice to take all the USB devices, see them in the house, and just drag and drop availability? You can just drag it to the workstations, and all of a sudden they've got connectivity. You can keep them isolated away from all, like the kids. You don't want kids, you know, getting access to certain things. All of that is very feasible. It can be micromanaged. It can be macro-managed. It's not a complicated model or solution. But with that, I wanted to just kind of bubble that up to you guys to just think about that idea of a true universal wireless communication switch solution, opposed to what we do today. This is Brad Dyke signing off. I hope this is helpful for you. I'm just having a moment of thinking about things in the future. I was going to do a few videos on that and see if you guys have any interest in that kind of stuff. I'm hoping that some of you are super smart and you can take these ideas and run with them. I'm 56 years old. I'm getting old. I can still think out the ideas, but I don't have as much energy as I used to in like my old days. Well, I'm going to sign off. I'll let you guys go, and you have a blessed evening. Bye-bye.